Hello everyone. So this is second part of GATE 2022 Organic Chemistry 2 marks questions. So in this question we have been given these two reagents, and as you can see from the first reactant that has been given, so this is SiO-methane OTF is present. So this is basically a benzyne intermediate formation type of compound, and CSF, which is a good base, as well as fluoride is present, also acts as the this benzyne formation. It helps in the benzyne formation. So what happens first is that the fluoride that is present in the CSF, having very good affinity for silicon, it actually attacks the silicon and it takes away the group, and that actually forms the benzyne, because OTF is actually a very good leaving group. So as you can see, OTF leaves. This is the arrow pushing mechanism that we can see, and the Me3SiF also leaves. So due to this, the benzyne is actually formed here. And once the benzyne is formed, then what happens is that we also have this the carbon compound that has been given to us, and this also has got two protons, and CSF is present as a base. So hence what happens is that enol type of compound is also formed. Basically enolate is formed, and after that this enolate actually attacks the benzyne, and hence we get our compound. So in the question, so this part is a little bit tricky, because this compound that we get after acidic workup, once the minus charge is actually protonated, so then this can also be a probable product. So in the options of the question of this question, so this product was also present. So this would also be a probable product, but this is a minor product. So this is not what is the major product. Hence in the question they have asked the major product. So we'll go for what is happening. What happens is that an intramolecular attack actually takes place after the minus charge is formed in the benzene ring. So what happens is that we also have a carbonyl center present, which is the ketone part. So the minus charge that is formed actually attacks in intramolecular fashion to the ketone part, and which then forms the COMe, and a minus charge is formed in the ester part. So that is stabilized due to the extended conjugation, and after the workup, the acidic workup, we eventually get our major product. So what is the answer to this question? So this is the major product that we get. So I was actually writing one carbon less, so sorry for that. And as we can see, hence this is actually our the product, the answer to this question. And all the H plus that I am writing after this in the last step, which is actually not given in the reaction, actually is the basically the workup, the acidic workup that is taking place. So no reason to be confused there. Yeah, so then this is the answer. And yeah, so thank you, and let's go to the next question. So in the next question, the reactant that has been given to us has got a plus and a minus charge. That is, it has got a dipolar present in it, and we also have a C double bond C, that is an alkene is also given in our first step. So this is actually the example of an 1,3 dipolar cycloaddition type of reaction. So let us see what this reaction is taking place here. So we have been given the Me C triple bond N plus O minus as a reactant, and also we have the Me CH double bond CH Me. And this type of 1,3 dipolar cycloaddition takes place to form a 5-membered ring with an NO bond. So this is the the 2-methyl group is in cis geometry in the alkene, hence also in the product that is in the 5-membered ring, they are in the same side. Now as we can see that H2 nickel has been given to us, which undergoes hydrogenation in the NO bond. So the NO bond is actually cleaved here, which gives which gives rise to NH and OH basically. So what we get is the NH and OH are present. The C double bond NH is formed, which is an imine, and the MeOH actually undergoes the imine hydrolysis. And as we know that any imine bond actually hydrolyzes to the ketone, or the carbonyl. So basically the C double bond NH here forms the Me C double bond O, and we have the OH as present, and the methyl groups are in the same side. So now just rearranging it a little bit to match it with the options, we actually get this as the product. So this is actually the answer to this question. So thank you, and follow the next parts for more solutions to the GATE 2022 Organic Chemistry 2 marks questions. And as I say, keep practicing and keep writing organic reactions.